Okay, so we have MT335. We've been having issues with a rough idling running issue. From my experience with high pressure common rails on Chevy Duramax trucks, I had a theory to look at the high pressure regulator. So I got one. I'll tell you more about this guy later if it ends up working. But now that I'm out here today, we borrowed the customer's Nexus diagnostic tool, which doesn't really tell us much. That's a whole nother video I'm going to do about whether this is even worth buying or not. But one of the things that I wanted to point out was that on the scan tool, it shows the rail pressure going extremely high. And from experience with surging idle and really high clackety, rackety idle, that's a sign that the fuel pressure regulator or the suction control valve on the high pressure common rail fuel pump is not working correctly. In that case, on these Duramax, for example, when you have the fuel pressure regulator or the suction control valve, which I'll show you what that looks like, which is this guy. If you have it unplugged, the rail pressure will be defaulted, or the pump will be defaulted in basically max rail pressure, which it'll build 26,000 plus PSI. And that much rail pressure against the injectors at idle will be extremely rackety and clackety. So if you have excessive rail pressure trouble codes, but it drives perfectly fine on the freeway, the reason is the rail pressure is high normally on freeway speeds under load anyway, because you're on high demand use of fuel. So one of the things that I did here was with that rackety clackety and that high rail pressure, I actually unplugged the suction control valve, which I'll try to show you here, is that green plug on the back side of the injection pump. I could probably show you a picture on a iPad or something to help you see it better. And it basically looks like this guy. It's got 2 bolts, slides out. So what I did though, and here's a trick for you. If you're ever working on those trucks or you're working on one of these, when the key is on, this thing is buzzing because it does not use constant voltage all the time to either open or close the valve. It's not an on-off switch. It's actually a pulse width modulation, which is actually why I'm using a lab scope here to diagnose this and kind of prove my theory. But normally you could, on a Duramax, turn the key on and then reach a screwdriver in and touch it and put this to your ear and you will hear it humming or buzzing. If you went on a computer and you went duty cycle and you increased it or decreased it, you'd hear the buzzing harmonically going up and down with it. In this case, if you put your screwdriver to this guy and it's plugged in, it makes no noise, which is either an indication that this is bad or the power supply to it is bad, which comes from the ECM. In this case, we unplugged the original one and plugged this one in and had no buzzing, but I also plugged that guy back in and I still don't hear any buzzing. So the theory is that it's a power supply issue or it comes from the ECM that's having an issue. Now, I'll actually show you here. This lab scope is set up to 100 millivolts maximum and 1 millisecond view. And normally you should have ignition power 12 volts to 14 volts in spikes up and then down to 0 and up and down. And I'll actually show you a clip from a video of a guy talking about how to do diagnostics of fuel pressure regulators on Bosch fuel systems. So for in this case, what I'm going to do.
Hello and welcome to PicoScope Guided Tests. My name is Mike Wilkinson. I work here at Pico Technology and this is a short video to show you a guided test on how to test a common rail diesel pressure regulator. So first of all, how do you get to the guided test? Well, I've got PicoScope all set up on my laptop here and we go to the top bar and click Automotive. We get a drop-down menu. Go to Actuators, and there you'll see Pressure Regulator. We'll click on that, and what happens is PicoScope loads up the scales required for you to capture a waveform. And on my screen now, you can see that I've got an example waveform of what a good pressure regulator waveform should look like. So, how do we actually measure the regulator? Well, first we have to connect it up. So, I've got channel A of my scope, and we need to connect it to the regulator, which on this vehicle, unfortunately, is at the back. So, I'm going to use breakout leads to do this, and it'll just take a minute or two. Excuse me. As well as connecting to the valve, we need a good earth. So that's it, we're all connected up. Now the guided test has a section which is how to do the test. And in this case, all we need to do is start the scope, run the engine, stop the scope, stop the engine. So that's what I'm going to do next. Okay, engine running, nice diesel knock, but on my screen I've got a waveform which is very similar to the example. Okay, so I'm going to stop that, and press the space bar or press stop. Turn off the engine, don't forget to slam the door on the customer's car. And what we have now is a captured waveform. If your waveform doesn't look like the preset and the example waveform that we've provided, then there's further help in our guided tests. You could go to the waveform library and have a look what people all around the world have been uploading. And there's further guidance, which is essentially written by our automotive specialists, and it will tell you all about the valves, how they work, and of course any potential faults. So there is help there should your waveform not be as expected. Okay, guided test, common rail diesel, pressure regulator. Thank you.
I'm going to turn the key on, so we should have power. And if you look on the lab scope, if this guy's connected still, I don't know if this guy's connected. We have 0.3 volt right there, but it should go up and down. It should be spikes, kind of like the video I'm going to show you in a second here. And because it's not, that means that this, obviously the fuel pressure regulator wouldn't be buzzing because there's not enough voltage to make it move. We're talking a 10 to 12 volt spike to zero with like this on a lab scope. And it's barely doing 0.3 volts across the board. And that's not normal. So theoretically, there's something wrong with the pulse modulation or fuel pressure regulator control, which theoretically comes directly from the ECM. In this case, we're going to do some more testing. I'll give you some more information, but theoretically, we may have to pull the ECM and replace it. I want to make a reminder that the clackety racket, and actually I'll show you right now. I'll show you what that sounds like. I'll start it. Noise in there because the fuel rail pressure is too high. It's basically overfueling, and it's putting a ton of pressure on those injectors. So normally, like on this truck right here, which is a Duramax, it'll run smooth as silk. And the second I unplug the fuel pressure regulator, it'll skyrocket to max rail pressure, which is like 26,000 PSI. And it'll sound really rackety clackety, and it'll have a horrible idle until I plug it back in and let that fuel pressure dissipate and level back out to, let's say, 1,000, 2,000 PSI in the rail. So on this guy, I'll actually show you. I'm actually going to start this guy back up. And this is actually going to be another video, is the diagnostic tool stuff, but I'll show you. However accurate this may or may not be, I'm going to go in here and right there. See how high that rail pressure is? I mean, it's probably not accurate at all, what it's saying, but if it's in the ballpark of that, I mean, 12,000, 40,000, I'm pretty sure it's not accurate, but I know. That's because I have the thing unplugged. My customer's pointing out that this red emblem is meaning emergency shutdown. That's just because of the check engine light for having the fuel pressure regulator unplugged. So the computer's registering that the sensor is there, and then it's I'm sorry, the suction control valve is plugged in and then unplugged, but for some reason it's not sending power to control or modulate the rail pressure. So that rough running, normally with a good system, it'll run like that, and then the second I plug it back in, it'll smooth right back out, and it doesn't in this case. So 20,000 kPa is a lot, but I don't think that I'm not sure how accurate this tool is anyway. So I have factory LS tractor software that I'm trying to get working on my laptop for this situation, and that'll actually be another video, like I said, for how to use the diagnostic software. In this case, the theory is that we have a ECM issue, but I'm just going to do a little bit more diagnostic to try verify that it's not for example, a broken wire or something like that. The problem here is I don't have a wiring diagram for this MT335. So the hard way to do it, which is possible, is I can back probe the connector and then basically ohm out continuity on this end and see if I can verify which ones they are. And then if I can verify continuity from both ends of the wire, the solenoid all the way up to the ECM connector, then I know that the wiring is good, potentially the solenoid is good, and therefore the only thing left would be the ECM. Okay, so continuing on with diagnosing, I want to verify that the wiring is good between the ECM and the connector. So if you look closely here in this video, which it probably won't show you, because iPhones suck. Remember, Steve Jobs made a shitty product. And it does not work. Anyway, here you go. That is a gray with red wire, if you can believe it. Gray wire, red stripe. What I did is I connected a test connector to that terminal, and it goes up to my voltmeter, and we're going to test for continuity. Continuity basically means that if you connect like a light bulb element or something, and signal can come through one test lead and through the other and complete one whole circle, this will beep. And I'll show you, kind of like this. If you touch your two leads together, this is one end, this is the other. You touch them together, you got continuity. So that's just for testing. Then you go all the way through that wire that's all the way in the harness. We tracked it back to this plug right here. And we look for the gray with a red stripe, which is right there. And then we go like this. Bear with me. Oh man. We go like this. We go like this, and watch this. It beeps. So that means that that wire is good all the way through. Now we're going to do it with the other one, which is a brown with a green stripe, which you can't really see in the video, but we're going to do that on the other one. So what we'll do is we'll swap this guy from here to this guy like that. Okay. Now we're going to look for the other wire, which, and if you notice what I did here is I cleaned it up and I found them and I put a little zip tie on them to help me find them later on. And this brown with the green is going to be theoretically somewhere on this lower half right here. There you go. It's right there. So now you hear that beeping noise. I got continuity. Tells me that that circuit's good. I'll leave that there actually for a second. And I got 0.3 ohms of resistance, almost perfect. So what that means is the wiring is good, potentially the solenoid's good, and therefore most likely the ECM is bad. Because if all your system stuff is good, the only thing that's left is the ECM putting out the control power to do that. Most likely a microchip or a controller or a relay or a circuit in the ECM is bad and it's not controlling the pulse width coming out to the fuel pressure regulator.